Okay, we're going to look at a problem that uses the Trapezium Rule. Now the Trapezium Rule is a numerical estimate to an integral. So if I have a look at this example, we want to integrate this function of 1 plus sine x all square rooted. At the moment we have no method of algebraically doing this, so we've got to use an estimate. And in this case we're going to use the Trapezium Rule using 5 ordinates. Okay, so 5 ordinates means really, well, if I give you a practical example, so here's the curve, say, for example, here's the x-axis, then 5 ordinates, there's 1, 2, 3, 4, 5, and you've got to imagine that they're all the same width apart from each other, okay? And it goes from 0 to 2. Okay, so 5 ordinates means 4 strips. Okay, so I can figure out what these other points are, so that must be 1, so that's 1.5, and that's 0.5. Okay, so that means that the length of the strips is 0.5. Okay, and we represent that using h. Now in order to start us off, we're going to build up a little table. So x and y. Now x is going between 0, 0.5, 1, 1.5 and 2. Okay, so hopefully I've left enough space for me to write these in. Let's see, shall we? Okay. Now, so effectively, what is y? Well, y is the actual function itself. So 1 plus sine x all square rooted. Okay, the bit that's inside the integral. Okay. So when x is 0, sine x, sine of 0 is 0. So you get 1 plus 0 is 1. Square root of 1 is 1. Okay, so that's just a matter of substituting in. Now, when x is 0.5, okay, I'm going to put it in my calculator. I do the square root of 1 plus sine of 0.5, and that's 1.216. So 1.216. Now when x is 1, square root of 1 plus sine 1 is equal to 1.357. 1.357. Okay, just for the record, I am using radians here. Okay, just so you're aware of that. Square root of 1 plus sine of 1.5 is 1.413. And when x is 2, square root of 1 plus sine 2 is 1.382. 1.382. Okay? So, now I can use the Trapezium Rule. Okay, the formula is in the formula booklet. So, the actual integral 0 to 2 of y dx, okay, where y is the 1 plus sine x all square rooted, of course. That's roughly equal to 1/2 times h, the height, 0.5, times the first term, okay, which is 1, plus the last term, which is 1.382, plus 2 lots, there we go, 2 lots of the rest. So 1.216 plus 1.357 plus 1.413. Okay, so 1/2 times 0.5 times the first term 1 plus the last term plus 2 lots of the rest. Okay, so I'm going to put that into my calculator. 0.5 times 0.5 times 1 plus 1.382 plus 2 lots of 1.216 plus 1.357 plus 1.413 close bracket equals 2.5885. Okay, so that is my estimate for the area under the curve.